So you guys have it says that 12 points suggested time 25 minutes. Now the old standard was 12 points. So okay. You guys got the truck versus the car. It says a car is stopped at a traffic light. The light turns green, and at time t0, the car starts moving and travels with constant acceleration. Okay, so the car's just sitting there, light turns green, it speeds up, starting from rest. At that instant, so at the instant light turns green, a truck traveling at constant speed, v sub t, as in speed of the truck is going to be v sub t, is alongside the car with the front of each vehicle at position x equals 0 shown above. You guys see this dash line marked x equals 0? The truck passes the car. I mean, of course it would have to, right? If the car starts from rest and the truck's just barreling through. Here, guys, let me make sure that everybody for sure understands what's going on. Here's the way I'm interpreting this, and I hope you have the same interpretation. I think the light's red, right? So the light's just red. The car's just sitting at the red light, just sitting, right? And then the driving the truck doesn't even notice the red light. He's just barreling at some constant speed, just coming through. And then the light turns green. At the moment the light turns green, the guy in the car hits the gas pedal, so speeds up from rest. And by a stroke of luck, that happened to be the same moment that this truck barreling through happens to reach the intersection. Okay? Because that light turned green exactly in time. Okay. Of course, the truck passes the car, but that car that's speeding up because it's accelerating later catches up to the truck in front of a house at time t sub d, so that each vehicle is in front of the house at time at position x equals d at the same time td. You guys got that? So they're both side by side at the intersection of the picture shown, but they're also side by side in front of the house. You guys got that? Okay. So on these axes below, you're supposed to sketch and label. Hey, look, it's a velocity versus time set of axes. Draw the curve for the car and for the truck. Now, when I say curve, it doesn't necessarily mean it's curving. It could be straight lines. Okay? General sense. Right? Okay. So what does this graph look like for the car? What does it look like for the truck? And then label each one of those. Okay? I'm going to read the rest of these with you guys. So part B says two students are discussing how the speed of the car compares to the speed of the truck when both vehicles are in front of the house. So in front of the house, suppose there's some guy in front, inside the house with a radar gun, and he's like measuring how fast are those vehicles, right? That's the question. Right? Student one, we've got student one and student two, because this is a common AP premise. They'll have two students discussing, and then maybe one or both are correct about something in what they say. Right? Student one says, well, the distance traveled by the car and the truck is the same, and the time is the same. They went the same distance and the same time, so they must have the same speed. And student two says, no, I don't see how that could be. The car has to catch up to the truck. So the car must be going faster when it catches up to the truck. So which aspects of student one reasoning is correct? And support your answer, relevant parts from the graph. Which aspects of student two's reasoning is correct, if any? Now, maybe each of them is correct about something. Maybe one's totally correct and one's totally incorrect. Right? You have to figure that out. Part C, derive an expression for the acceleration of the car in terms of the distance traveled and the speed of the truck. Okay? Now, what's a little bit tricky about this derivation is you could express the acceleration of the car maybe multiple different ways. Okay? Guys, do you guys notice they did not mention in terms of time? So can you come up with a derivation that's only in terms of distance traveled and the speed of the truck, but not in terms of the time? Maybe it substitutes out possibly some way, or maybe you can figure out. Great, there might be different ways to get that. Okay? And then D, determine the time in which the speed of the car is equal to the speed of the truck. Express your answer in terms of the time to reach the house, T sub D. Justify your answer. Okay. So they're recommending 25 minutes here. I read it with you guys, so that'll knock off a few minutes. Here, I'm going to throw 18 minutes on the clock. I'll see how you guys are doing. And then we'll go over the answers, and we'll see if we can do that before the end of class. All right, so there you go. Clock is ticking. Walk around, check on you guys. All right, so back recording. A lot of you guys did really good on this. Okay, so let's go over this. So notice they give you a velocity versus time graph. They could have said position versus time. They could have said acceleration versus time. Those would look different. Okay. Now the truck's going constant velocity, so I would just do like v truck. It'd just be some constant value like that, right? Constant. Right? And looks like most of you guys got this right for the car also. Okay, so there's a truck. Now the car would be speeding up from it, so wouldn't it be like this straight line? Right. Now, what a lot of you guys caught is that suppose I go like this, right? Okay. Is that so it calls the car? Guys, where those two lines intersect, that's where the cars have the same what? Velocity, the same velocity. Okay, right. But there's a different question floating around, which is when both cars are in front of the house, that means they move to the same what? Distance, right? So velocity, that's a different concept. Guys, what property of this V versus T graph tells you how far the cars have moved? Area under the curve, right? So if I see where the two lines cross, the area under the curve for the truck, well, that would just be a rectangle shape. The truck's going to be however many squares that is, right? But for the car, that's not a rectangle. That's a what? A triangle, which means up to that point, the car's only moved what proportion of the distance? Half. Isn't that triangle half the area of that rectangle? Right? So the car's not even caught up to the truck. The truck's twice as far out as the car is when they have the same speed, right? Whoever has a radar gun, oh, it's the same speed, then the truck's way ahead of the car. Right? You have to let this roll forward to right about here. Ding. Cause T sub D. Okay. Now. Okay. You guys see the area of this rectangle? That represents how far the truck has gone, or how many tiles that is. Okay. Look at the area of this triangle. Is that the same area?
Yeah.
Yes, it is. Okay. At a glance, you can tell because if you take some scissors and cut out this little bit up here, can you dump that upside down and it exactly fills in with the rest of this rectangle? Yeah. Right. In fact, when they're both in front of the house, which would be at this TD, the car is traveling exactly how many times as fast as the truck? Twice as fast, right? Which is going to be important later when you do that derivation. You can say at this moment, the V car equals 2 times V truck at TD. Okay. So let's look at points here. How to store points. So part A is about this graph. Here's the scoring key. They got car, truck. You guys see car and truck. This was for 3 points. The first point for a clearly labeled horizontal line for the truck. You guys have a colored pencil within reach? Colored pencil? So start marking this. We're going to go up to 12 points. We'll go as far as we can today. So if you gave a horizontal line for the truck, give yourself the first point. Second point for a clearly labeled straight line with a positive slope for the car. So if you have something that looks like this, straight line with a slope, constant slope, labeled car, that's the second point. And the third point is for the speed of the car ending higher than the speed of the truck at the time labeled to indicate that the house has been reached. Right? Now, you guys said more specifically, the speed of the car should be exactly twice the speed of the truck. But if you don't have that exactly, as long as you have the car going faster than the truck, then they say, okay, go, you get all 3 points. Okay? Got all 3 points. Right, part B. This is where the two students are talking. Student 1 says the distance is the same and the time is the same, so they must have the same speed. Guys, what about that is correct? Do they move the same distance in the same time?
Yeah.
Yes, they did. Okay, so you could write that. In fact, that means they have the same, not instantaneous speed, but what kind of speed? Average speed. In fact, if you said that too, that could help support that. How about here, let's look at double I. Student 2 said, I don't know how that could be. The car catches up, the car must be going faster. Is that also true? Yeah, but he's not talking about average speed. He's talking about instantaneous speed, right? In front of the house. Right? And that's where the car is going twice as fast instantaneously if you point a radar gun, right? So they scored this out of 4 points. 4 points. First point for indicating student 1 is correct that the car and the truck have traveled the same distance at the same time. That's the first point. Second point for identifying a feature of the graph that can support this. For example, guys, what feature of the graph tells you how far the vehicle's traveled? Area under the curve, which is exactly what it says right here. The area of the rectangle, the area of the triangle are the same. Or the visual average. Visual average. Guys, here's what visual average is. Well, here's one thing about average. Guys, what if I made an aquarium? You guys see my aquarium right here? Right, aquarium walls, and I have a block of ice. You guys see a rectangle block of ice? And it melts. It's basically the same, right? What if I have a triangle block of ice? You guys see that block of ice? And then I let that melt. Is that exactly overlaid with the same average? That's how you find an average value, right? Average value. Right, double I. All right, so now we're on to student 2. How was he correct? Student 2. Okay, 1 point for indicating that the car speed is greater when both vehicles are in front of the house. True. When they're both in front of the house, the car is going faster. In fact, it's going exactly twice as fast. Right? Second point, for identifying a feature of the graph that supports this, well, we're talking about coordinates. So the fact that you're ending with a greater coordinate for the car compared to the truck. So I would just point that out. What about that? Derive an expression. Here, I know we're getting real short on time, so I'm just going to show you guys my derivation. Guys, the fact that they do not mention time, they don't want you to get acceleration in terms of time. Would that be, they can maybe start off with a third kinematic formula? All right. Car starts from rest, 0 right there. The final speed of the car is twice the speed of the truck. Right? You can solve this whole thing in just 4 lines right there. All right, so there's the bell. Yeah, all right, see you guys. We'll finish. You guys, hold on to this FRQ. We're going to finish scoring this tomorrow.